day 424 off the grid. Now look, here's my main control panel in shed A, and you may notice something a little bit different there. There's the 500 watt sine wave inverter. Where's all the clip leads and the circuit board and the wood and all that stuff that was there? And what's this? What's this? Well, on this day I finally got around to encasing my linear regulator. Yes, finally. I checked out the last video that I did on this. You know, the linear regulator, a new old approach video, part 5 I believe was the last one. And that was in October 2014, so it's been a long time and many other things have come and gone since then, but on this day I finally got round to it. I got round to it certified, so I didn't mess around, I got onto it. It's one of those things, why did I particularly choose to do that on that day? I'm just going to turn on the lights because it's a little bit dull here at the moment, isn't it? Weather's not so good today. Well, this was kind of a bottleneck really, having all these sort of vulnerable wires and stuff hanging around in here in this rather small shed. As you can know, it's a very small shed I have here. I mean, my head's touching the roof as I stand here and my legs are slightly bent. It was just one thing that was just a real sort of clumsy hazard, a real, you know, accident waiting to happen really. And it was probably preventing me from getting on and doing other things in the shed to some degree, so it really needed to be done. And it's been sitting there for nearly 18 months and I haven't made any major changes to the circuit, so I deem it's pretty much sorted. So there it is in the case. In fact, the only thing that's been added since it was sitting here was, you can actually see it inside there, that capacitor is just added there to stabilize a part of the circuit, which is the bit where the control voltage feeds that transistor in there, the emitter follower, that ultimately feeds the power transistors. And that was the only component that I've added to this since it's been sitting around. So now I've cased it up, of course, I've made it a bit more stylish. I got this missile switch, which this replaces my clip leads for when I want to select between a sort of absorption equalized charge up to 14.5 volts that I do occasionally, or might leave that like that more often in the winter, or snap it down, and it's what I called the low gear. So I added that, yeah. So there we go. Put it in this cool case. You know, none of this click-clack stuff like my other projects on here. This is a purpose-built industrial case that I got cheap from JCar, and it fitted this board nicely, so I thought, why not, eh? Why not? So that's really it. That's the solar power regulator, a new old approach, complete. It's done. So I briefly just take you over how this setup here works again. You probably already know, but the main part of it is actually not that, it's this. This here is just basically a voltage controlled relay, and it's a design I developed way back before I even had solar panels really, when I was just interested in controlling the charge to a battery. In fact, this is the very first prototype I built. It's had a few changes to the threshold circuitry and stuff, and it's even gone through a couple of components that I've replaced, but it's essentially the first circuit. So this is for the A bank, the 12 volt A bank, which is basically what I consider the main bank of the system. And it's simple really, this relay here is now what actually switches the juice from the solar panels. And it basically, when the voltage drops below 12.8, this relay will close, thus connecting solar power from this output of this diode up here. This big blue thing's basically a diode, directly through this blue wire and into this junction here, which I am going to update at some stage soon too, down through these breakers and into the AGM batteries. When the voltage reaches to 14.4, the relay will open. thus then bringing the regulator system over here into play. So it's sort of an old school way of doing it. So basically when the voltage is low, it's just hardcore switch to the solar panels. No devices, no resistance or anything in the way of the solar panels, apart from the internal resistance of the contacts, wires, diode, blah blah blah. And then when it reaches that 14.4, all of a sudden it's got this variable resistance of these power transistors to deal with, which are regulated by this regulator control here. That's basically it. There's a couple of tricks that I've done to improve the circuit for the situation of being a solar rig, and one is that I've explained back in one of my earlier videos, which originally was this here. It was originally a piece of coat hanger which I called koltanga, yes, but that subsequently got replaced with this bit of galvanized, basically fence wire, which does form a resistance, although it's a little bit lower in resistance, and it dissipates better. This only gets warm to the touch when it's got like 20 amps going through it. And the reason why that resistance is there is so that the collectors of these transistors here can be held below the voltage here, which is on the other side of the diodes, which this then feeds to the base of the transistor. Now, if you don't know much about electronics, that'll just sound like a load of gobbledygook, but what that basically means is by lowering the collector voltage a little bit, it allows the base voltage to be pushed up and the transistor to turn on harder. So it makes the linear regulator actually work more efficiently. But you're going, oh, but you're dropping power across this resistor up here. Yes, but if that power wasn't being dropped across that resistor, it would just simply be being dropped across transistors, because after all, transistors are really transfer resistors. That's why they're called transistors. So it allows me to turn on the transistors harder and to share some of the power dissipation with the transistors and this resistor, so therefore these don't have to work quite as hard or get quite as hot. So that's basically that. But the main point being of today, I've cased this up. It's a pretty simple circuit really. There's a Zener reference down the bottom here, and this Darlington sort of medium power transistor is an error amplifier. And then this really old school, it's like a miniature version of a TO3, it's like another medium power transistor, is the driver transistor, which is an emitter follower which supplies the voltage to these ones. Now there's a relay here, and that's because every time I build a project, especially if I'm building it from scratch and making it up as I go, as a lot of the time it is, sooner or later I will make a bodge, you know. I'm sure some of you can relate to this. I'll be working on something, try to craft it, trying to be really neat, and next thing you know, I've made a bodge. And sometimes it's like a clumsy thing, like drilling a bit too fast through something and cracking something, or something like that. Or sometimes it's just a complete mechanical oversight, like something's in the wrong place, so that when you put it back together, put the thing back together, it doesn't fit together because it's fouled on something. You know, things like that. Bodge. Well, my bodge with this project wasn't cracking the panel or putting something in the wrong place as such. No. What it was the switch I chose to go underneath this missile cover. And if you can look through there, you might be able to see it. It is basically, it's a single pole, single throw switch. So it's an on-off switch. It's only got on and off. And I figured that was all I needed, because all I'm trying to basically do is short out a diode, or let that diode be in circuit. So of course that's all I needed, obviously, right? Fine, but the missile switch complicates things, because what I really need this switch to be is when the switch is off, that's the high power mode, and when the switch is on, shorting out the diode, that's the low power mode. But of course a missile switch is configured so that when it's down, the switch is off, and when it's open, you can turn the switch on. And you can't really put it around the other way, because there's a locking piece in here that only allows it to fit onto the shaft of the switch one way. Yeah, you could file that off, but then I would have been faced with another problem, and this is a mechanical issue. The position where I mounted the switch would not allow it to be spun around. So I would have had to have had my missile switch so that it's open and on most of the time, and then shut when it's on the high power mode, and that just wouldn't have been cool, would it? So I ummed and ahed over a few things to do, including actually drift this hole up a little bit and install a 2-position switch that I could have then done the job with, and I didn't really want to do that because then that would have been a mechanical bodge, you know, having this extra cunty hole there. And so in the end I came up with well, it's not electronics, an electrical solution. I installed this relay. And this relay is just simply super glued to the front of this panel, so you can actually see it work. In fact, should we watch it? Watch the relay. I'm going to turn it on. See? Relay's on, relay's off. So basically what this relay does is it inverts the operation of the switch. So that when the switch is on, the relay actually opens a circuit which lets that second diode come into play. And when the switch is off, the relay closes the circuit. And of course, since it spends most of the time in the off position, the normal way I've done this is use the normally closed contacts so that the relay most of the time is not sucking any juice. So it's no big deal. I'd only be having the relay on during the days when there's lots of sun anyway, but it's only a relay. I mean, it doesn't even use 100 milliamps. But then I thought, well, you know, this isn't such a bad thing after all, because now I've got this relay in here. If I ever want to automate this process and have it switch automatically between these two levels, which could be really useful, I've already got the situation in place to do that. I don't have to add it now. So it was kind of like, it wasn't such a bodge after all. But that's why the relay's there, to cope with this being an on-off switch. But I'm pretty pleased with how it turns out. Looks pretty cool, especially at night with this light lighting up the interior. It's a pity there's no LEDs or something else in there glowing away, but it's, you know, it's cool. You know, I've got enough LEDs inside things like this here glowing away, haven't I already? So, you know, that's it really. So that's my regulator complete. It seems to serve the purpose perfectly fine, and I have no real intentions to you know, I don't really need to develop it further, or I don't need to swap it out for a commercial one or anything like that. There's no use having MPPT on this whatsoever, because there is such a motley collection of panels in the array powering it. It would never find a decent power level anyway, I would imagine. And the main thing in Shannon is the preponderance of cloudy days, although fortunately we haven't had too many of them right now, and MPPT will really not help with that whatsoever. I understand it would help if you had a succession of cloudy days and then one cold morning the sun comes out blazing in the middle of winter, you know, and then it would help bring those batteries up maybe a bit faster, or maybe it wouldn't. But I'm working on the principle of having enough solar panels that I can sort of keep things ticking along even on a cloudy day, and keep the generator runs over winter to a minimum. And I really hope to do better this year than I did last year, although last year wasn't too bad. That's it really. Yeah. Anything else what I say? Oh, the fan. Yeah, the fan helps cool the transistors down, obviously, and that's just wired to the other contact of this internal relay, so that when this switches over to regulator mode, this relay here gets turned off, but then power comes through this resistor and powers up the fan, so the transistors are cooled whenever they're regulating. Pretty simple really. Sometimes they're being cooled more than they need to be, of course, because there might not be that much voltage dropped across them, but that doesn't matter. So yeah, that's basically it. Day 424 off the grid. That's what I did, and I'm really pleased that I got that installed. It's a pity we haven't had enough sun today. Like, it's sort of coming out all right now, but there hasn't been enough sun during the day to actually reach regulation mode today, so I can't flick the switch and show you the voltmeter, but maybe I'll do that another day if I remember. So there we go. See you later. Wow, it looks pretty groovy at night, doesn't it? There's the missile switch. Well, there. Yeah, thought it looks pretty cool.